All right, we're going to be taking a look at rational exponents. So with rational exponents, you'll notice here the power is a fraction. And when the power is a fraction, in this case x to the power of m over n, the n represents the nth root of your expression. So if this was a 2, this would be your square root. If this was a 3, this would be your cubic root, your third root. 4, obviously your fourth root, etc. And then inside is x to the power of m. So let's look at an example here. I can show you guys sort of what to expect. So let's say we had 2 to the power of 3/2. Using exponential notation, we have 2 to the power of 3/2. If you write it in radical form, it would be the square root of 2 to the power of 3 or the square root of 8. Now, normally in math, we write square roots so much that they actually omit writing that 2, and it's just written as root of 8. So I'm sure most of you have seen this idea of a root, the root of a number. It's actually considered to be the square root or the second root, right? And the reason for that is that denominator of 2 is underneath. Okay, let's look at another example here. Suppose we had 10 to the power of 5 over 7. Now this would be the seventh root of 10 to the power of 5. Now equivalently, I think we all know that x to the power of m over n, you can rewrite it as x to the 1 over n to the power of m, right, using your basic exponent laws. If you haven't seen the video on your basic exponent laws, I will link it in the top right-hand corner. But at any rate here, m over n can be expressed as x to the 1 over n to the power of m, because power to power we multiply. X to the 1 over n is just going to be the nth root of x. So you can rewrite this as the nth root of x and then take the power of m afterwards. So for example here, even if we reference the question we just did, we were looking here at 2 to the 3/2. You could write that as the square root of 2 and then cube the result, right? In the previous example, referencing the previous example, we had 10 to the 5 over 7. I could write this as the seventh root of 10 and then raise it to the power of 5. These are equivalent. So these are going to be both the same. You can take the seventh root of 10 and raise it to the power of 5, or you can take 10, raise it to the power of 5, and then take the seventh root. These are equivalent expressions, and we're going to see that we can use these ideas going back and forth when it helps us. All right, let's look at our first example here. So writing this in radical form, this would be the third root of -8, the entire expression squared. Well, that's going to be the third root. -8 squared is going to be 64. And now I need to think of a number that I multiply by itself 3 times to get 64. And that number is 4. Okay, likewise, let's try the next one here. Okay, so this question here, we have a negative exponent. If you remember, when you have a negative exponent, you can just flip it and change that sign to positive. Now this would be equal to -8 to the 2/3. And now we would have the third root of -8 squared, which again is going to be 4. It's the exact same question as we just had here, if you notice. They just kind of rewrote it in a different form. All right, let's take a look at the next one. This is 64 to the power of 1/2. So this is going to be the square root of 64. And again, like we talked about, the square root is written so often, notationally we omit that, in which case the answer here would be 8. Right? 8 squared is 64. Let's continue. Now this one's interesting here. The power of a third is only touching the 125. So this is really negative the third root of 125, which would be negative 5 times 5 times 5 is 125. So this would be -5. This one here, same idea. The half here as a fraction would be 1 over 2. So this is just the square root of 400, which is 20. Continuing on here, this will be 81 to the power of 1/4, which is the fourth root of 81. And the fourth root of 81 is 3. All right, let's look at the next one here. Now they want to express as a single power. Right now this is expressed in radical form. So as exponential form, this would be 19 to the 1/5. Right, the power on this 19 is a 1. That's the place of your m. And therefore, this would be 19 to the 1 over 5. Okay, likewise, to express this as a single power, the power on -91 is a 1. So that's the place of my m. So this will be -91 to the 1 over 3. And again, like we talked about, this is actually should be a 2 here. So this is to the power of 1. So this is going to be 29 to the 1 over 2. Okay, more expressed as a single power. So now let's check this out. So now again, in exponential form, what's going on here? Well, we talked about how this can be rewritten as the third root of 10 squared, in which case here this is going to be 10 to the 2/3, right? Your root is always on the denominator. The third root, second root, fifth root of the expression is your denominator, and the power is in your numerator. Same with this one here. Like we discussed, I could rewrite this as 12 to the power 5, taking the fourth root, in which case this is 12 to the 5 over 4. Same idea here. This would be 36 to the 3 over 7. All right, let's continue. So this one here, whenever you apply an exponent, it applies to the top and to the bottom, right? If you square a fraction, square the top, square the bottom. Same with a half. If you raise something to the power of a half, it's each the numerator and denominator get applied to that power of a half. So in this case here, this would be expressed as 9 to the half over 16 to the half, which is the square root of 9 over the square root of 16, which is 3 over 4. Same idea with this one here. If I wanted to do this using my exponential notation, I want to apply the half first, and then I want to cube the result. So in this case here, this will end up being, and like we just talked about, the root of 49 and the root of 25 you're taking here. So a root of 49 is 7, root of 25 is 5, and now you're cubing your result. So in this case here, this becomes 7 cubed over 5 cubed. And 7 cubed is 343, and 5 cubed is 125. This one here is an easy one, right? Power 0, like we talked about, anything to the power of 0 is 1. Okay, now we get into some simplification questions here. So take a look here. Again, BEDMAS rules apply. You have to take care of the brackets first. I'm completely ignoring this half, saving it for the end. So this is going to be the third root of 8. This, they want the third root of 27. And this, they want the third root of 64. Well, the third root of 8 is 2. The third root of 27 is 3. And the third root of 64 is 4. Well, 2 plus 3 is 5, plus 4 is 9 to the half. So this is just the root of 9, and the answer is really nice, comes out to be a 3 here. Okay, same idea here. We want to simplify this. So this is really just asking for the root of 9 minus, okay, we just discussed this, right? If you have a negative exponent, it's equivalent to flipping it and change that sign to positive. Now I don't need to divide something by 1, so I can just rewrite this as 8 to the 2/3. And now this will be the root of 9 minus, this will be, again, like we talked about, you can take the third root first and then square your result. So this is root 9 minus the third root of 8 is 2 squared. The root of 9 is 3 minus 2 squared is 4. And your answer here is going to be -1. All right, last question here. Again, a big simplification going on here. Using your BEDMAS first, so we're focusing all our attention on that. So I'm going to write everything else back down. So this is going to be the third root of 125. Here we're taking the fifth root of 32, and then I'm going to do that power 4 afterwards, plus the square root of 36, close the brackets, and square the result. So now we're taking the third root of 125 is 5. Now here, if you take a look here, the fifth root of 32 is 2, because 2 to the power of 5 is 32. So this is actually going to be 2 to the power of 4, plus the square root of 36 is 6. Now again here, this is going to be the third root of what? We have 5 plus 2 to the power of 4 is 16, plus 6 squared. And continuing on here, we have the third root of 5 and 16 is 21. This is 27 squared. The third root of 27 is 3 squared. And lastly, the final answer here is 9. So there was a lot to unpack in this question. Now you should check it out yourself. Try to redo it. Again, I encourage you guys, pause the video, try the questions out yourself, and see if you can get 9, work your way to 9. And same with all the other questions here, right? These are all great questions. Pause the video, try to get to 3. Pause the video, try it yourself. Try to get to -1 without looking at the solutions. But at any rate here, this is an introduction to negative exponent rules. I think we've covered a lot of ground here, and this is how you work with negative exponent rules. Thank you.